Alright, let's get started. First of all, determine if the quadrilateral is a parallelogram. If it is a parallelogram, state how. Number one, yes, this is a parallelogram because both pairs of opposite sides are congruent. Second one, no. This is not, you cannot prove this is a parallelogram. If this side and this side were also congruent and parallel, then yes, it would be a parallelogram. If these two sides are parallel and congruent, yes, it would be a parallelogram. What we know is these two sides are congruent and these two sides are parallel. That is not enough information to prove that is a parallelogram. Third one, yes. Both pairs of opposite angles are congruent. The last one, these two parts are congruent and these two parts are congruent. So yes, the diagonals bisect each other. All right, the next one, trapezoid, ABCD. AD is 8x minus 20. RS is 3x minus 6. AB is 4x minus 7. And DC is 13 minus x, and we simply have to solve for x. The mid-segment theorem says if you add the bases together, and the bases are the parallel sides, that's 4x minus 7 plus 13 minus x, divide them by 2, so you're finding the average of the bases, equals 3x minus 6. That's going to be 3x plus 6 equals 6x minus 12, 3x equals 18, x equals 6. The next one, the figure is an isosceles trapezoid. So we know the legs are congruent. Therefore, these two angles are congruent. So now we have 3y minus 4 equals 56, 3y equals 60, and y equals 20. These two angles right here, this one and this one, are consecutive interior angles, therefore they are supplementary. And we know this angle is 56 degrees because it's congruent to this angle. So 5x plus 4 plus 56 equals 180. So 5x plus 60 equals 180. 5x equals 120. And x equals 24. The next one, ABCD, is an isosceles trapezoid. AC, which is a diagonal, is congruent to BD. In an isosceles trapezoid, the diagonals are congruent. So we know AC is congruent to BD. Therefore, 6x minus 11 equals x plus 14. 5x equals 25, x equals 5. Number 8, DEFG is a parallelogram. Since this is a parallelogram, we know the diagonals bisect each other. These two parts are congruent. These two parts are also congruent. So 2x equals, these two are equal, 2y minus 4. And we know the other two are also equal, GH and HE. So we also have 2y plus 1 equals 3x. I, personally, am going to solve for this x right here, but I could have solved for this y right here. Actually, I'll solve for y. 2x plus 4 equals 2y. You do not always have to solve for x first. Y equals x plus 2. Substitute this x plus 2 in for this y right here. So you're going to have 2 plus 2y plus 1 equals 3x. And in that parentheses, you're going to put x plus 2, because this is equal to this, which is also equal to that. Therefore, they're interchangeable. You can substitute in there. So you have 2x plus 4 plus 1 equals 3x. Subtract 2x from both sides. X equals 5. Substitute 5 back in right here. 5 plus 2 is 7 for y. Solve for the variables in the rectangle. This angle is 140 degrees. Notice this is a rectangle. As a result, the diagonals are congruent and bisect each other. So this is congruent to this, which is congruent to this, which is congruent to this. Therefore, this right here is an isosceles triangle. This angle right here is 40 degrees because these two angles are supplementary. So this is now a triangle, isosceles triangle, so you have 180 minus 40 is 140. Divide by 2, that equals 70 degrees. So x is 70. So if we put 70 right here, this angle right here is a right angle, so therefore this angle has to be 20 degrees. This triangle down here is also an isosceles triangle, therefore y is 20 degrees. Number 10. Use rectangle. Again, you have a rectangle. A, B, C, D, and the following information to find the missing lengths. AC is a diagonal, 7x plus 10. BE is 5x minus 7. Again, the diagonals of a rectangle are congruent and bisect each other. So we need all these parts right here are congruent. All right, so we have 7x plus 10 is the whole thing there. This part is 5x minus 7, which means this is also 5x minus 7. So BD equals 5x minus 7 plus 5x minus 7, which equals 10x minus 14. And we know AC is congruent to BD. So 7x plus 10 equals 10x minus 14. 3x equals 24. X equals 8. Did I answer the question? No. The question says find DC. So DC equals 3 times 8 minus 2, which is 24 minus 2, which is 22. All right, number 11. If BAC, remember your angle is always the middle letter, so it's that angle right there. If BAC and the measurement of angle DAC, which is right here, so BAC equals 3x plus 4 and DAC equals x minus 6, find BAC. BAC. So we're going to find this angle right here. So we know this is a rectangle, and this angle right here is 90 degrees. Add them together. So 3x plus 4 plus x minus 6 equals 90. 4x minus 2 equals 90. 4x equals 92. X equals 23. Make sure you answer the question. So the measurement of angle BAC equals 3 times 23 plus 4, which is 73. Number 12, solve for the variables in the given rhombus. First of all, you need to remember your properties of your rhombus. The diagonals are perpendicular. Therefore, every angle right here is 90 degrees. So x is 90 degrees. The other thing you have to remember is that it is a parallelogram, so opposite angles are congruent. And the diagonals bisect the angles for a rhombus. So if this angle is 24 degrees, that means this angle is also 24 degrees, which also means this angle is 24 degrees. That also, you could look at y and 24, they're alternate interior angles. So, y is 24 degrees. Now, if you look right here, this is a right triangle. These two angles, z and 24, must add together to equal 90 because this angle is already 90, and three angles in a triangle equal 180. So 90 minus 24 equals z, and z is 66 degrees. Number 13, given the rhombus, we know all sides in a rhombus are congruent. We could do this multiple ways. I'm going to say let 2a plus 2b equal 3a plus 6, just like we do with all the other parallelograms. So we have 2a plus 2b equals 3a plus 6. I'm going to subtract 3a. Actually, I'm going to I'll subtract 3a. So that's going to give me negative a plus 2b equals 6. I'm going to write my second equation. 5b minus 4 equals 6a minus 3b. So I'm going to get all my a's and b's together like I did here. I'm going to subtract 5b from both sides, and that's going to give me negative 4 equals 6a minus 8b. So I'm going to line those up. Negative 4 equals 6a minus 8b. I am going to use elimination to solve this problem. Notice that this is a negative 8 and this is a positive 2. I'm going to eliminate b's, so I'm going to multiply this by 4. That's going to give me negative 4a plus 8b equals 24. Now I'm going to add these two equations right here together. That's going to give me 2a, negative 8b plus 8b is 0b, which is 0. 0 times b is 0, equals 20. Therefore, a equals 10. To find b, substitute 10 back into one of your equations. So 2 times 10 plus 2b equals 3 times 10 plus 6. So we've got 20 plus 2b equals 30 plus 6. 2b equals 30 plus 6 is 36 minus 20, which is 16. So b equals 8. Number 14. Use the square ABCD and the given information to find x and y. Angle DAC is this angle right here, equals 10y. This is a square. A square is both a rectangle and a rhombus. Therefore, each of these angles is 90 degrees and the diagonals bisect the angles. So that means that each of these angles is 45 degrees. Therefore, 10y equals 45, y equals 45 over 10, which is 9/2, which equals 4.5. To find x, we have BAC, angle BAC, which is again 45 degrees, but it also equals 5x. So 5x equals 45, x equals 9. Number 15, angle AEB. The diagonals of a square are perpendicular and congruent because they have both the characteristics of a rhombus and a rectangle. So angle AEB, so 9x equals 90, x equals 10. Number 16. One side of a kite is 4 centimeters less than 3 times the length of another. So I'm going to let this side be x, and I know this side is congruent to the side, so this side is also x. Well, it says this other side is 4 centimeters less than 3 times, so this is going to be 3x minus 4, which means this one's also going to be 3x minus 4. If the perimeter is 72, for perimeter, you add all 4 sides together. So x plus 3x minus 4 plus 3x minus 4 equals 72. Well, combine your like terms, solve for x, and x equals 7.8. Make sure you answer the question. Find the length of each side of the kite. Well, this is 7.8. This is 7.8. Substitute 7.8 in there. This side is 28.2. This side is also 28.2. Next one. The measurement of angle KIT is 78 degrees. Remember, this diagonal, which is the line of symmetry, bisects angle E and angle I. So if angle KIT equals 78 degrees, the measurement of angle KIS equals 39 degrees. That's 78 divided by 2. Okay, and the measurement of KET is 52 degrees, so the measurement of angle KEI equals 52 divided by 2, which is 26 degrees. So this one right here is 26 degrees. This one right here is 39 degrees. So they want the measurement of angle IKS. Remember that the diagonals of a kite are also perpendicular. So now this right here is a right triangle. These two angles right here have to add together to equal 90. So the measurement of IKS equals 90 minus 39, which is 51 degrees. Okay, same concept for angle SKE. They want this angle right here. These two angles have to add together to equal 90. So the measurement of angle SKE equals 90 minus 26, which is 64 degrees. ITE, angle ITE, which is this entire angle right here, is congruent to this entire angle right here. Well, this angle is the sum of IKS and SKE. So here's IKS, which is right here, and SKE, which is right here. So simply add these two angles together, and that's going to give you 115 degrees. All right, next one. You have to prove that this is a parallelogram. Let's plot the points and look at them. First point, 2, negative 6. 2, negative 6. Next point, 4, negative 2. 1, 2, 3. Next one, 7, 7, negative 5. So this is A, this is B, this is C, and D is at 5, negative 9. So it says if one pair, so one pair, we're talking about one pair of sides are parallel and congruent. So we have to do the slope twice and the distance formula twice. So I'm going to use AB and CD. So AB is parallel to CD. First, let's prove that. So AB, the slope of AB equals negative 2 minus negative 6 over 4 minus 2. Remember, this is plus, so 6 minus 2 is 4, 4 minus 2 is 2, so that equals 2. The slope of CD is negative 9 minus negative 5 over 5 minus 7, so that's going to be negative 4 over negative 2, which also equals 2. So they are parallel. Yes, that is true. So now we just have to show they are congruent. So AB, the distance for AB, D equals the square root of 2 minus 4 squared plus negative 6 minus negative 2 squared. That's going to equal the square root of negative 2. Make sure that's in parentheses, squared, plus negative 8 squared, and that equals the square root of 4 plus 64, which is the square root of 68. That is for AB. So let's look at CD. D equals the square root of 7 minus 5 squared plus negative 5 minus negative 9 squared, and that is going to be 2 squared plus negative 5 minus negative 9 is 4. So that is 4 plus 16, which is the square root of 20. So no, it is not a parallelogram. Because opposite sides are not congruent. All right, the next one. If I want to go from the origin to this point right here, I know that I have to go right A and up B. Therefore, since this is a parallelogram, I know that from this point I am going to have to go right A and up B to keep it a parallelogram. So I added AB here. I'm going to add AB here. So my new points for T are R plus A and 0 plus B, which is just B. All right, the proof. Let's look at what we know. We know that we have a parallelogram yogi. And with that being said, I know that G, B, and BY are congruent, and BO and BI are congruent. And we know that this is a vertex angle, therefore that implies that it's a vertex angle of triangle BIY. Therefore, that is an isosceles triangle, and these two sides are congruent. If these two sides are congruent, and these two sides are congruent, this side and these two sides are congruent. There you go. For this to be a rectangle, we need to show that the diagonals are congruent. So we need to, everything we just put down and talked about in this picture, we need to actually put it down in a proof. So we have a statement, all right, so here we go. Parallelogram yogi. And B is the vertex angle of isosceles triangle BIY. And that is given. All right, next step. What else did we talk about? We know that BI and BY are legs of an isosceles trapezoid. So we're going to put that in our proof. So BI and BY are legs of isosceles trapezoid. Reason. B is the vertex angle of isosceles triangle BIY. Now, next step. We know that BI is congruent to BY because legs of an isosceles triangle are congruent. Alright, next step. We know that BI is congruent to BO, and BY is congruent to BG. So BI and BO are congruent and BY and BG are congruent because diagonals of a parallelogram bisect each other. Alright, we also know that BY is congruent to BO and BI is congruent to BG through substitution. So BY is congruent to BO and BI is congruent to BG. Right here we said BI is congruent to BY. So I substituted in right here. So if BI is congruent to BY and BY is congruent to BG, then BY is congruent to BG. Again, if BI is congruent to BO and BI is congruent to BY, we also know that BY is congruent to BO. So that's substitution. Alright, we also know that BI plus BO is congruent to IO. And we know BY plus BG equals YG. That is the segment addition postulate. Alright, well, if BI is congruent to BG and BY is congruent to BO, we can substitute in right here and say that BG plus, again, BO is congruent to BY, so BY equals IO. That was substitution. Alright, now we know that YG is congruent to IO because we said BY plus BG equals YG. Well, I can substitute this YG in here. So YG is congruent or equal to IO. That was substitution. Therefore, Yogi is a rectangle. Because diagonals bisect each other. And they are congruent. Next page. Okay, here we go. Polygons. Alright, so let's just extend this line right here. This angle right here is 95 degrees. Notice that's an exterior angle. This angle is an exterior angle, 70 degrees. This one's an exterior angle. Let's extend this one, 40 degrees. Let's extend this one, 90 degrees. The sum of the angles of an exterior, or sum of the exterior angles of a polygon are 360. So we've got 70 plus 95 plus 90 plus 40 plus m equals 360. M equals 65 degrees. The second one, this is a hexagon. Again, the sum of the exterior angles must be 360. This angle right here is 59 degrees. This one is 90 degrees. This one is x, x, x. This is 82 degrees. So that's 1, 2, 3, 4, 5, 6. Add them together. You're going to get 3x plus 90 plus 59 plus 82 equals 360. X equals 43 degrees. We already know that A equals 59 degrees, so B is 180 minus 43, which is 137 degrees. All right, find the interior angle and exterior angle of a regular 24gon. Okay, exterior angles are way easier to find, so because we know the sum of the exterior angles are 360 and we know the interior and exterior angles are supplementary. So we're going to find an exterior angle first. 360 divided by 24 equals 15 degrees. 180, and this is your exterior angle. Interior angle 180 minus 15 degrees equals 165 degrees, and that is an interior angle. The next one, how many sides does a regular polygon have? If its interior angle is 162 degrees, find the exterior angle. 180 minus 162 equals 18 degrees. That is an exterior angle. 360 divided by 18 equals 20 sides. Alright, 25. Find the equation of a line perpendicular to 10x. Alright, perpendicular lines have opposite reciprocal slopes. First we need to find the slope. So we have negative 4y equals negative 10x plus 3y equals positive 5 halves x minus 3/4. My new slope is, the perpendicular slope is going to be negative 2/5. So now y minus 1 equals negative 2/5 times x minus 2. Y minus 1 equals negative 2/5 x plus 4/5. Add 5/5 to both sides. Y equals negative 2/5 x plus 9/5. Alright, 26. Find the equation of a line parallel to 2y equals 3x plus 8. We know parallel lines have the same slope. So y equals 3 halves x plus 4. Use your point. Y minus 5 equals 3 halves times x plus 4, because this is a negative 4. Distribute. Y minus 5 equals 3 halves x plus 6 y equals 3 halves x plus 11. Okay, construct an angle bisector. So let's see if I can use this one here. So first thing you're going to do, we're going to draw an arc. Then you're going to use those points that you just made, stretch this out a little bit past halfway, and we're going to draw arcs up here. Then we're going to move this over here to this point, and we're going to draw another arc. Of course, those two arcs should intersect, and if they don't, you're going to have to redraw that arc. Move that, put in your line, and your line's going to go from here to this intersection point right there. There you go. All right, next one. Construct a segment perpendicular to the given segment through the given point on the line. Okay. So you're going to put your pointer here, and we're going to draw an arc so that it crosses this line 2 times. Not going to use that point and that point. That's not what the question's asking. It's asking you to draw a perpendicular so that it goes through this point and it's perpendicular to this line. It doesn't say make a perpendicular bisector, so these 2 points have nothing to do with it. So what you are going to use are these 2 points right here, this point and this point. Then we're going to use this, and we're going to draw arcs again. So we want to stretch this out so it's a little bit past halfway between here and here, which this one is. So we're going to now draw arcs from the points that we just made. And again, these arcs should intersect. So now use your straight edge. You're going to draw a line from this point down through the point of intersection. There you go. All right, next one, last one. So construct a segment perpendicular to the given segment through the given point on the line. Okay, almost the exact same thing as this one. You have a point. These 2 points have nothing to do with this. So we're going to put our pointer there. We're going to draw an arc. So we're going to now use this point and this point because they are equal distance from this point. Now we're going to use those 2 points. We want to stretch our compass out because we want to draw an arc. And I'm going to draw an arc. So I'm going to start up here. I'm going to draw an arc. I'm going to stretch my compass out a little bit more because I don't like where that arc is going. So I'm going to draw an arc. I'm just going to go around like that. Then I'm going to come over here and I'm going to draw the same arc. There you go. Now I'm going to use my straight edge and voila, there it is. So now we're done. Do not forget that anything from September may show up on this test. We may have parallelograms, we may have truth tables, we may have similar triangles, we may have congruent triangles. Anything may show up on this test. So, good luck.